How's it going, you guys? In this video, we're going to be talking about modeling with quadratics.
Oh, you're so pretty. You walk down the runway so well. Yeah.
Uh, Not really what I mean, but anyways, what all this is essentially modeling. Really, this is going to come helpful whenever we get to a problem like this, where we're given a real-world situation and we are able to find a model of a quadratic given some data points. So first, I'm going to show you a way that we can find what an equation could represent of these data points. So this one says find an equation in standard form. So remember, standard form is y equals ax squared plus bx plus c, where your vertex is negative b over 2a, and then you can find your y values from there, blah, 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 through the points of the parabola. So what we can do, notice we're given a y and an x value, an x and a y, an x and a y. So it has to be going through all of these points. So one thing we can do to make our lives a little bit easier is we can say that this is negative 19 equals, I don't know what a is, so if I plug this in, 2 squared plus b times 2 plus c, then I have a system of equations. And again, we can do it with this point as well. I can plug it into our general form, or our standard form, sorry. We call it different things in pre-cal sometimes. So we have negative 3, and I'll put in negative 2 now. So a times negative 2 squared plus b times negative 2 plus c, and 7 zeros, so negative 7 a times 0 squared plus b times 0 plus c. So now what I can do with all of those equations is just like we did in the last chapter when you guys were doing matrices, is we can make a matrix. So we have 2 squared is 4a plus 2b plus c equals negative 19. And then we would have 4a again, but this time minus 2b plus c equals negative 3. We'd have 0a plus 0b plus c equals negative 7. So we already know c is negative 7, but we can make this into our matrices. So we would have a 3 by 3, so we can do the a inverse b stuff. So if I make matrix a 3 by 3, where I have 4, 2, 1, 4, negative 2, 1, 0, 0, 1. And then I can make matrix B a 2 by 1. Sorry, 3 by 1, right? 3 rows. It's negative 19, negative 3, negative 7. Then we can go back to our main screen and do A inverse B to solve it. So hey-oh, all that tells me is A is negative 1, B is negative 4, C is negative 7. So let's remember that. So, well, really, we don't even remember it. We can just write it out, because y equals, A is negative 1, so negative 1, negative 1 x squared, B is minus 4x, and C is negative 7, so minus 7. Now remember, you don't need to write that negative 1, so really you'll see us write it as negative x squared minus 4x minus 7. And that's our equation. So same sort of idea, we would do the same thing with this one. So we could set up our equations, set them up in matrices. I want you guys to go ahead and try that, and then I will come back with all the work and I will explain it. Boom! All right, here you go. So we have, again, standard form is ax squared plus bx plus c. If we're given some x and y values, we can substitute them in to find 3 equations, which we can write so that we can put as matrices. Put them in your matrices. You will find that a is 3, b is negative 6, and c is 0, so we won't really need to put plus anything. So we have 3x squared minus 6x. Hey-oh, that's my parabola. All right, part C is the same idea. I'm not even really going to work this one out with you guys. Just remember, this is f of x. So all it's saying is that this comes from the point 0, negative 2. This is the point 2, 8. And this is the point 6, comma 16. So again, you would do the same thing. Plug in your y and x into your standard form equation. Plug in your y and x into standard form, y and x into standard form, write as a system of equations, and find your equation in standard form, which is how the calculator gives it anyways. All right, the other way that we can do these problems, especially if we have data and we know it's going to model a quadratic function. So it says the table shows the height of a kicked monkey. Pow! after time. So if I take a monkey and I drop kick him, right? Big man, kick, monkey, foot, boot, monkey, go, fly, right? If the monkey flies, the monkey will go up and he will eventually have to come back down to the ground. Well, if you look at all of that motion, that forms a quadratic motion. So it says find an equation to model the data. Should say find a quadratic. And we've done this before, except we only did it with linear modeling. So if you remember, good for you. But we can do some statistics with some given information. So we're going to go to stat in our calculator. So I hit stat, which is right there, and we want to edit our lists. So say if we have stuff in that list already, notice my cursor is moving from 18. If you want to clear out a list, you can go to that list, press clear. Note that's blinking down. That is blinking down here. Press enter, and it will clear the list. But what we want is we want that information in there, so that we have our x values and our y values. And to model an equation, we want to go back to our main screen. We want to calculate. So notice I went to stat again, and I moved over so that I was on calculate up here. Now I want to do a quadratic regression. Remember, we were doing linear before. Now we're going to do quadratic. So choose quadratic, press enter, and hey-oh, that's your equation. So I'm just going to copy it down exactly as it looks. So we have y equals negative 1.375x squared plus 17.75x minus 12. Right? So that would be our model. It's just what our calculator is telling us. So now it says find the maximum height. So what we can do is we can type into our calculator, go to your y equals, so we can actually see the graph of it. We can type in negative 1.375x squared plus 17.75x minus 12 and see what it looks like. Whoa, that's crazy. Well, let me put it in a standard window and see if that does anything. Well, that looks even crazier. So here's something that is a pretty cool trick. If you want to change how your calculator is viewing things, you can go to window. Window is right here. So when I press window, it takes me to this. It says x minimum. That is how far left on the side you want to go. Well, say we're starting at 0 time, and say we hold them up there for 100 seconds or whatever. We can go by tens, so that's x maximum is the highest, so how far to the right you want to look. Scale is what each tick mark represents. So y min, well, we can't go below the ground, so we'll make that 0. Y maximum, I don't know, maybe we kick them 400 feet in the air or something. It's probably not going to be that high. And let's go by, say, 40s or something. So if I look back at my graph, whoa. That is really, really tiny. So if I remember on my x's, we were going by, what, 10s or something like that? And then my y's were going by 40. So I'm going up 40 feet. So let's change that a little bit. So let's make this be a maximum height of like 50. And let's go by 10s. My x max, let's make that 15. And we can probably go by 1s on that. So now look at my graph. That looks like a better picture. So what we can do is now we can calculate stuff with our graph. So if you hit second trace, notice right above trace in blue it says calculate. We can calculate a maximum or minimum value or even some zeros of our functions by using our calculator. But if I want to find the maximum, because that had a highest point to it, I choose maximum. Now it takes me back to my graph and it says left bound. So all that wants is there's this little cursor here. It wants you to move the cursor such that you are to the left of the maximum somewhere. It doesn't matter anywhere, but you just want to be to the left somewhere. So if I choose that, then notice that little arrow came up, and it's all that's saying is the calculator is going to start from here and it's going to look in the right direction from there. Now this changes down here. It says right bound, so you want to get to the right of your maximum. Press enter again, and another little arrow came up. So all that means is your calculator is going to look for a maximum between these two arrows. See how they're kind of pointing towards each other? Guess, it doesn't matter if you want to try to guess where it is. Your calculator is going to do it. So I just press enter one more time. So now this tells us our maximum is happening when time is 6.45 seconds, or whatever our time is, might be minutes. That's a long hang time though. And our maximum height would be 45.28 whatever this is. Say we're all in feet here. Feet. So our maximum height would be 45.28 feet. All right, check out your homework. You guys will get a lot more practice on this as you do your homework. Please, please, please come in and ask me questions. I'm here for you guys. Love you guys, and I will see you soon. Bye-bye.